Login accepted.
All right, so welcome to week 4, and for this week we'll be talking about pen testing a Linux system. Sign in link again if you haven't looked at it, but it's also in the chat. So,
hello everyone. I am Jimmy again. I'm a third-year CS major. Right now, I'm an intern at Sony for threat intelligence. I was the webmaster / Linux for CCDC last year. And for CPTC, I was an alternate, and now I'm a team member.
and then it's me again. For CCDC, I was the alternate threat hunter, and now I'm currently the threat hunter. And then for CPTC, I was an alternate pen tester, now a pen tester on the team. So here's where we are. Again, we are on the Linux section. Before we talked about web applications, and next week will be Windows. So here's the agenda for today. We'll first be talking about common services, what they are. Then we'll be talking about tools to actually test those, or to test those services and other applications you may find on a Linux-based system. Next, we'll be talking about attacks and how to actually perform them. And finally, we'll be going through a decently lengthy lab. So without further ado, we'll start with common Linux services. So what exactly is a service? We've kind of gone over this in CCDC, but it's essentially a program that's running in the background that the end user will eventually interact with. This program is this program doesn't need to be managed by the sysadmin because it's instead managed by the system itself. Since Linux is a server, since Linux is generally a server environment, these services are very common on said environment. So first, FTP. FTP, or File Transfer Protocol, is kind of like a folder on the network. Depending on the permissions you actually have, you can interact with it as if it were a folder on your own computer. You can do things like add a file, remove a file, modify it, download it, etc., etc. For a lot of these services, generally speaking, the service itself isn't going to be vulnerable. Instead, it's either the contents they host or something on it or something in it that you'll be looking for. So in this case with FTP, generally speaking, the service is not vulnerable unless you have an outdated version like ProFTPD's 1.345 or VFTPD 2.304. But the contents inside it may be useful. To actually access these contents, depending on how it's set up, you may be able to access it without credentials at all, with either an anonymous or guest account, or if it's more secure, it may require actual credentials. Again, if the contents inside the FTP server are sensitive, this is something we can actually use. If it's credentials, we may be able to use them to escalate, laterally move, or even get onto the system itself. And if it's something like PII, we may be able to report that to our client as something that they need to address. Next, we have SSH, or Secure Shell. SSH is a way for a system administrator to actually manage their Linux server remotely. And since it's a server environment, this is generally how they're going to actually manage that system. So because SSH is generally secure, instead of exploiting it, we are going to use it as if we were a normal user. To actually authenticate to the server, depending on how it's set up, we may need only credentials, we may need a authorized private public key pair, or we may need both. If you have some sort of file read onto the system, and it just so happens to only require a key pair. If you can find the key, if a user has poorly left their private key somewhere that's predictable, and you're able to actually read it, you may be able to use that key to actually authenticate onto the server. Next, we have port 80 and also port 443. This is going to be HTTP and HTTPS, which is the secure version that's encrypted through TLS/SSL. These ports can host a bunch of different services on them sorry, let me rephrase that. A bunch of different services for web servers use these ports. Stuff like Apache and Nginx both use port 80, I think by default, unless you change it. So there's going to be a lot of overlap on this specific port. But again, you aren't really testing the service, you're testing what's hosted on it. So as Linux itself is generally secure. So in order to actually successfully pen test it, you're more likely to exploit either third-party applications or custom applications that they've created themselves. And so in this case, you're trying to pen test, or you're trying to test the web application that they're hosting on this service. And we went over that last week, so a lot of those things apply here. And with that being said, there is something that can be useful. Or sorry, that being said, if you actually have access to the files on the server that relate to the web application, depending on how that web application interacts with anything else, say a database, there may be files inside the web root that contain useful information. With a database, if it's poorly authenticating into the database to actually access it, the credentials may be left in plain text. So you may be able to use those credentials that normally the web application would use to interact with the database to instead connect to the database itself and possibly exfiltrate some information that may be useful. Speaking of databases, we have MySQL. There are a bunch of different databases that you can find on a Linux server like Redis, MySQL, Postgres, but MySQL is a very common one, so we'll be talking about it here. A database stores information. So if you're able to connect to that database, you may be able to extract that information. So if the application that's using it is doing some sort of authentication, there may be credentials stored in the database. So you may be able to extract those credentials and use them to your own gain. So next, we'll be talking about some tools that you may find useful when pen testing a Linux-based system. First, we have Msfvenom. This tool should be familiar since it was part of the homework for week 2. In fact, this command right here is actually what you can use to generate an ELF payload to target a Linux system. So we don't really need to talk about it too much. It's part of the Metasploit framework. It is the payload generation tool of the Metasploit framework. Next, we have 2 different enumeration scripts, that being LinEnum and LinPs. These scripts essentially run a bunch of different commands to try to enumerate the system to the best of its ability. What that means is that it will try to find stuff like what operating system it's running, what users are on the system, what services are on the system. It'll attempt to enumerate their versions. It may attempt to identify any binaries, and any binaries with the SGID bit or SUID bit enabled, and more. While I'm not too familiar with LinEnum, I am more familiar with LinPs, and these tools can be very useful in finding out where to actually go when you land on a Linux system. These are some very useful reconnaissance tools once you're actually on it, on the Linux server. So once you find some information from your reconnaissance, say you find a binary that you're not familiar with, that doesn't seem to be installed on a Linux server by default. Since Linux, again, is inherently secure, you're going to want to test that system. You're going to want to test that third-party application since it may be vulnerable. And GTFO bins is one way of finding out if something like a binary is vulnerable, depending on what permissions it has or what permission it has. So if you find a binary that you're not very familiar with, you can throw it into GTFO bins, and it will tell you what you can do with that binary and how to exploit it. Say you have something like Vim, and it's got a SUID bit, or say you have Vim and you have sudo access over it. If you were to throw that into GTFO bins, it will tell you under the sudo section that you may be able to do a Vim escape through calling in a terminal. Next, we have Pspy. Pspy is an incredibly useful and powerful tool that allows you to monitor for processes that are running in the background. This is incredibly useful if you assume or if you think that there is something running in the background, whether that be a cron job or a script that you can't actually confirm, since you may not have read access to the directories needed to actually confirm that. What you can do is you can run Pspy, and if that script or cron job fires off again, you may be able to detect it and see what it's doing. This is incredibly useful if you're attempting to hijack that process, or even figuring out what the system is doing. If you've done Hack the Box, this tool will be very familiar, since for a lot of easy to medium boxes, if it's not going to be sudo for that final privilege escalation, it's probably going to be a process that you're going to hijack, and you're going to find it through Pspy. Next, Google. Google is going to be incredibly useful when you're testing a Linux system, simply because you're going to want to test third-party applications. You may find a third-party application that you don't recognize, and you don't really understand how it works. You can always throw it into Google to understand how it works and maybe how to exploit it. Don't forget keywords like pen test or your Google OSINTing tips, the Google dorking tips, since those can help you refine your searches and help just speed up this process. And finally, file transferring. This command right here isn't the greatest on an actual client environment, since if you were to use it, it's unencrypted. And so if there was someone else on the system, some other actual malicious actor listening on the network, they may be able to perform a man-in-the-middle attack and loot what you're attempting to loot yourself. However, for general use, a quick Python server can be very useful for transferring files. And to actually access those files, you can always do something like curl or wget, depending on your preference. Next, we have Jimmy with attacks.
All right. Could you go to the next slide? Thank you. So like Marshall was saying, a lot of the initial access is going to be through a web app or outdated services. So there's a pretty low attack surface for Linux. So we'll be covering mostly privilege escalation techniques in the presentation. So the majority of these attacks make up, could you go back? Thank you. So the main attacks are SUID, SGID, environment variables, weak file permissions, kernel exploits, SUDO abuse, and cron jobs. So once you get onto a system, it's important to kind of inventory and see which types of attacks you have access to. This could be through seeing through LinEnum or LinPs, where you could see outdated software running or the version of the system to get a general idea of how the box is running and what's on it and what you have access to as well. So the first general way of escalating your privileges is insecure file permissions. So in Linux, this makes up a pretty big portion of the privilege escalation techniques. So usually, if there are weak file permissions, say for example, you have write access to Etsy password. So this could be vulnerable since you're able to create your own users with your with any ID. So for example, if you have an existing user with an ID, user ID, you could replace it with 0 as the root ID to elevate your privileges, or you could make a whole different user, a whole nother user. So similar to Etsy password, we also have Etsy shadow. Wait, Marshall. Thank you. So Etsy shadow is also a vulnerable file where if you're able to read it, for example, you could try to crack hashes of passwords of other users. So a lot of native files like that Linux uses for authentication, like Etsy sudoers or PAM files, could be overwritten if you have access, or if there are weak file permissions, you might be able to escalate your privileges through there. So it's really knowing what permissions look like to these important files and what you have access to as a user. Next slide. Thank you. So another attack path you could do is if the SUID or SGID is set. So what these stand for is set user ID and set group ID. The SUID or the user ID allows you to execute a file or script as the owner of the file. So for example, if the owner of the file is root and you have execute permissions or the SUID is set on that file, you're able to execute it with root permissions or as root. This is the same with SGID, where it allows a user to execute with the permissions of a certain group. And these could be exploited with the use of GTFO bins. If you're unfamiliar with a certain binary, you could just look it up to see if there's an SUID for it to grant yourself a privileged shell. So in the picture, we could see that instead of the X for execute for the permission bit, we have S instead. So this signifies either the SUID or the SGID, which are specified in the owner octet and the group permission octet. There's also the sticky bit, which is the T, which basically means that if this bit is set, only the owner of the file or directory can modify it, preventing these type of attacks. But if the sticky bit isn't set, you are able to abuse it and use it to get more privileges. Next slide. So this is an example of kind of finding an SUID manually. So we use the find command. We search through the binary directory, which is all your commands. And we also have the perm and user flags. So for the perm flag, we have the perm flag is set to 4000, 4 being the SUID bit and the other 3s being any other permission. So once we search through this, we could find a list of SUIDs, but then we also want to filter the owner as root, so we could escalate our privileges. So we could do this by using the user flag and the root argument. So once we found a malicious binary, a lot of these SUIDs are native to Linux, and it's kind of hard to tell. So it's really good to look at GTFO bins and see whether or not you could escalate from these binaries. In this example, we have bin bash, which does have a path to escalate. which is shown in the right, where we could do bin bash tag p to grant us a root shell. Like Marshall was saying earlier, sudo access and sudo abuse is also a big portion of vulnerabilities or things you could do on a Linux system. So sudo permissions are when you run as you may all know, when you run a file as root or when you're granted privileges to run a file as root. So these permissions are set in etc by root to have access to a certain binary or a certain command to run a certain script. To check these, you could use sudo tac-l to see what files or what permissions you have to run as root. And this also finds the files that have no password for sudo, which means you don't have to authenticate to use sudo on that file. A good tool to check if these sudo files are vulnerable is fall of sudo. And it basically just automates seeing which sudo lines that show up can be exploited and which ones you could use for your own benefit. So this could be vulnerable if you have write permissions to a certain file, or let's say they use wildcard characters to run a certain directory or something like that, and you're able to modify it. So these are ways you can get code execution on the system. In this example, the user has sudo access to Python for the remote management Python script. So another way you can escalate privileges through this through sudo abuse is to, if you have a program running, try to crash it to default to a debugger shell or something like that. So in this example, we have this remote management script. On the left, we have the user connecting to the remote management script through port 4268. So once the user is authenticated, it shows the menu of things we could do. So we could view processes, view free memory, and stuff like that. So since it's looking through a value from 1 through 4, if we try to use something like test to try to crash the program, as we could see on the right side, it crashes, and then it gives us a Python debugger little instance. So through this debugger, we're able to read files in the root directory, meaning we escalated our privileges successfully. So onto cron tabs. A lot of you probably know this already, but it's basically a task scheduler for Linux. So if there are insecure file permissions, like if you have access to a script that's run by root, or if it uses wildcard characters to run all the files in a certain directory which you have write access to, it could be a way to get elevated privileges. Also, if the path isn't set, if the cron tab path isn't set for a certain script, you could potentially overwrite this script with your own malicious script to get execution as well. Like Marshall was saying, Pspy is a good way to find these cron tabs running and kind of what's running on the system as well. So onto kernel exploits. Kernel exploits are basically vulnerabilities in the operating system itself. So it would affect all Linux versions or that particular version of Linux. And the way to fix this is just to update the system or update the kernel. This could be found through linps or LinEnum. The screenshot shows an output by LinEnum with the outdated kernel version. If you want to do this manually, you could cat the proc version file and use searchsploit or another tool to try to find a exploit for this particular version. In the example, it's using dirty cow, or the exploit is dirty cow, which relies on a race condition which is basically when two processes run at the same time, leading to really weird behavior. So once you find this particular outdated version or whatever, you could look up a POC online or try to see if there's any available code to run on the system to get to escalate. So another thing we could do is modify the path variable. If we are if we have sudo access or a file has an SUID to run as root, we could potentially modify the path variable to call our own commands instead of the ones in the file. So how the path variable works is it's basically a list of directories to sort through for defined binaries. So in this example, we have the following directories. So the one that's searched through first would be user local sbin, then second would be user local bin, and then so forth. So how hijacking works is if you append your own directory that you have write permissions to before the user local sbin or the first one, instead of searching through the other directories for the binary or the command you want to run, it'll search through your directory. And if you put like a malicious file with the same name as the command, it'll run that instead of the actual intended command. All right, so now we have a little demo of this. Give me 2 seconds to pull it up. Okay, can you guys see that? Nice. So basically, we have this script, the C script. So this, you don't really need to know much about how it works. It's a lot of just formatting, but it basically just runs this ping command and returns the output. So to check if you have sudo access to the files, you could do sudo tac-l. And then it looks like we have access to the compiled version of the script. So if you want to hijack the path, you could set the path to the current directory, which we have write access permissions to, and then append the rest of the path to the end. So before I do this, this is the current path. And then once we set it, it changes to this. So now we have, now instead of searching the normal directories for the binary we want to run, it'll search our bootcamp directory first, which we have write access to. So then we could make our own little malicious binary that runs a command. And since we're running this script as sudo, it'll run it as root. So the output should be the ID of root. We also need to set the file permissions to execute so that it could actually run our malicious binary. So if we sudo and then vulnerable, we could enter the IP and then it runs as root. But then if we remove this file, then it should just run the script normally. So that's a little example of how the path variable could be manipulated to get our own code executed on the system. Okay, so there are other vulnerable environment variables as well, along with the path variable. There's LD preload and LD library path as well. So what these environment variables do is they load shared object files. So these are kind of like libraries, which are reusable code that if you don't want to keep rewriting it in the scripts or whatever, you could just load in your shared object files, and it'll run the code for you. So this could force programs to use their own functions over the existing ones that are provided in the original code. And to exploit this, if you're able to run a script or a script with pseudo privileges, you could preload these custom shared object files that you write to overwrite these overwrite the functionality without actually having to change the first script itself. And then LD library path is kind of like the path variable, which is directories that are separated by a colon, and it sorts through these to see where the shared object files should be loaded. So the first one is search first, second one is search second, and so forth. So to exploit this variable, if you create a malicious shared object file, which allows, you could create a malicious shared object file and then set the LD library path to your directory, which we have write permissions to. So in the following example, we have a little shared object file that can be used to get elevated command execution. In this file, you don't really need to worry about the include statements on top. We have the init magic method, which basically runs on execution of this certain file. Within this magic method, we have three functions that are called. The first, we have the unset environment function, which removes a current environment variable. So in this case, we're removing LD preload. We're basically unsetting it so that it doesn't interfere with our exploit later on down the line. We also have the set re SUID, which sets the effective, real, and the saved user IDs to 0, which is root. So this allows us to execute whatever we want as the root user, or the user with the ID of 0. So then next, we just execute the bin bash tac p like we've seen before to get an elevated shell as root. Now for the lab. So for the lab, there's two boxes on the environment. There's Linux 1 and Linux 2. Linux 1 is a little bit easier. It has a black box approach, where you could only, you don't have much information on it and you're going in blind. And then Linux 2, the harder box, you need to get access to Linux 1 first and use the creds found on Linux 1 to laterally move to Linux 2. So the goals are to find as many vulnerabilities as you can and get root on both machines. For the homework, you'll need to write up about how you exploited one of the Linux vulnerabilities you found in the lab, including screenshots, and explaining how it works. You also have write-ups on 2 try hack me rooms and questions to answer as well. Let us know if you have any questions. We're open to helping out.